Welcome to solverfy, the place where learning becomes simple. If you're struggling with homework, assignment, or doubt in subjects, don't worry, you are in the right place.
Hello everyone. In this problem we have to calculate the resultant force acting on the frame due to forces 300 Newton, 500 Newton, 400 Newton acting at different points. So we are replacing these forces by a single force on the frame, and we have to calculate moment of these forces about the point A. So there are two problems. 300 Newton force we are naming to be F1. This is to be named F2 and this is to be named F3. Now we will write the component of F1, F2 and F3. So F1 is at this point. This point we are marking to be P point. I am writing here, this is P point. There is a little bit less space here. So this is your P point I am marking here. This is Q point and say this is R point. You may see here. Now F1, this is the X component of F1 and this will be the Y component and this angle is given 30. So I am expressing F1 force into component form. So it will be 300 cos of 30 I cap minus 300 sin of 30 J cap. When you solve it, cos 30 is root 3 by 2. You will get 260 Newton I cap near about minus 150 Newton J cap. This is F1 force. Say this equation is 1. Now F2 force I am writing here. F2 force is along x-axis. You may see the figure. So this could be written as 500 Newton I cap. Now F3 force is along negative y-axis. You may see the figure. This is the direction negative y-axis. So you may write minus 400 J cap Newton. This is your third. Now resultant or single force acting on the frame, you can write a vector addition of F1, F2 and F3. F1 we have measured 260 Newton I cap minus 150 Newton J cap. F2 is 500 Newton I cap and F3 is minus 400 Newton J cap. On simplifying the resultant force on the frame, we will get it would be 760 Newton I cap minus 550 Newton J cap. Now we can express this in vector form. We can express it according to the diagram. Let us see here. We can draw the diagram of this resultant force. This is x-axis, this is y-axis, negative y-axis. This will be the resultant force and you can find the direction by finding this angle. So magnitude of resultant force we will get root of 760 whole square x component का square plus y component का square root. So this magnitude would be 938 Newton and direction is theta is tan inverse of, see the figure, this angle we are finding 550 divided by 760 and on solving this angle will be 30.59 degree. So this is the resultant force. You may highlighting it. This is the resultant force on the frame acting. Now we have to calculate moment of force. Now we are finding the moment of force on the frame. About the point A, the moment of force we can define by the cross product of rotating arm and force. So for point F1, rotating arm is AP because F1 is acting at P point. So AP cross F1, F2 force is acting at Q point. So rotating arm will be AQ vector, AQ cross F2, and F3 is acting at R point. So rotating arm of this force is AR, AR cross F3. Now substitute the value. You can see the figure. AP vector can be written as minus 0.5 j cap, and F1 is 260 Newton I cap minus 150 Newton j cap. AQ is minus 1.5 j cap. See the figure, you can easily find. And F2 is 500 I cap plus AR vector. AR vector is 0.5 I cap. You can see its coordinate, so you can easily write it. And F3 is minus 400 j cap. Now find the cross product of all these forces. So you will get 130 Newton meter K cap plus 750 Newton K cap minus 200 Newton meter K cap. So this resultant would be 680 Newton meter K cap, or we can also write 680 Newton meter in anti-clockwise direction. So this is the answer for this problem. Thank you for